Well, welcome to today's ParaBoss webinar. For those of you who are new to ParaBoss, ParaBoss is Australia's resource for the control of worms, lice, flies and ticks in cattle, sheep and goats. It's a joint initiative of Australian Wool Innovation, Meat and Livestock Australia, the University of New England and Animal Health Australia. My name's Fiona MacArthur and I'm a member of the ParaBoss Extension team. And today we're going to be talking all about effective flystrike management in sheep. And we will be joined shortly by Narelle Sales. Just a little bit of housekeeping for you before we kick off though. The webinar is recorded and that recording will be available on a YouTube channel in the near future. And you can access that at any time. There are two tabs if you're new to Zoom, the Q&A tab and the chat tab, and I'd really appreciate if you could use these for different functions. The first is the Q&A tab. In here, I want you to put all your questions for Narelle. At the end of today's presentation, we will have ample time for a Q&A session. So that's where I'll pull your questions from for that. The chat function, if you could use that if you need a hand with anything technical behind the scenes with the Zoom platform, I can answer you directly there. All of those Q&A questions and chat comments are not available to the attendees, so you're only messaging me. So we're just going to kick off with a poll question before we get going. I'm going to launch the poll for you now, and there's just two short questions in here. And the first one is, what is your industry role? And a few options here: advisor, sheep producer, education, so student or an educator, other, a goat producer, and mixed species producers. And the second question you'll see if you scroll down is where you're located. So Queensland, New South Wales, the ACT, Victoria, South Australia, WA, Northern Territory, Tasmania, or internationally. These polls are really helpful for us here at ParaBoss. We get a lot of valuable information from the polls, and it allows us to help deliver information to you better. But also it will be very helpful to Narelle before she begins today to know who you are and where you're from. Polls are all anonymous and only I can see your votes, but I'm going to share the percentage of votes to you on the screen in a moment. I've just got 80% of people who have filled the question in, so I'll leave it open for a little bit longer. And I'll end the poll now, and I'm going to share the results on screen with you so you'll be able to see. We have 39% of people today are advisors, 18% are sheep producers, 5% are education from the education division, 32% other, 0% goat producers, 7% mixed species producers. And where are you all from? 9% from sunny Queensland today, 57% from the New South Wales and the ACT, 18% from Victoria, 5% from South Australia, 7% from Western Australia, no one from the Territory, 2% from Tasmania and 2% from overseas. So thank you very much for filling that poll in, and wherever you are from, welcome today to our webinar. So I'll hand over to Narelle now. I'll turn my webcam off for you all and I'll click through the slides for Narelle as she needs them. Enjoy, everybody.
So good afternoon, everybody, and thank you, Fiona. As Fiona said, we did a practice yesterday and had no technical difficulties, but obviously today the gremlins are in. So my name is Narelle Sales and I work at the Elizabeth Macarthur Agricultural Institute at Menangle in New South Wales on ectoparasites of livestock and predominantly biting lice and flystrike on sheep. We currently have a jointly funded project between AWI and New South Wales DPI, looking at insecticide resistance in Licilia caprina, the Australian sheep blowfly. And I will talk about this later in the webinar. So Fiona, next slide, please. So let's quickly just go through some of the basics. There are three basic things that are required for flystrike. And the first one falls under weather. So the conditions that are required, the temperature range that is mostly quoted for fly activity is between 15 and 38 degrees Celsius. but there is, they will be active outside this range depending on what life stage you're talking about. So, for example, in the cooler weather, larvae will remain active on sheep because, of course, they benefit from the warmth of the sheep's body. And above 38 degrees, they won't be flying to strike sheep, but it doesn't mean that they're dead. They will still be around, and they tend to go to areas of vegetation where it's cooler and there is some moisture, and they can usually get through those sorts of temperatures so that when the temperature decreases, they can start to fly again and become active. Yeah, 15 to 38 degrees is the area that we talk about as the active area for Flystrike. So the second requirement is moisture, and we usually say that sheep need to be moist for about 3 days. That moisture can be delivered by intermittent showers of rain, or a really good shower of rain, and then the drying conditions for the sheep after that shower of rain are poor, so the sheep remain damp. So one of the things that is a good thing to do is monitor the weather condition on your property, and pretty soon you'll see the correlations, and you'll be able to set up thresholds so that you know the amount of rain that you need for your sheep in particular at that wool length. And there can even be variations between how quickly a mob of sheep can dry out, depending on how windy a paddock is or not. Another thing to use, there's several tools around weather and strike prediction. For example, Ag 360, which is the latest upgraded version of what you may be familiar with as Ask Bill. And there's also the ParaBoss Flystrike risk simulator that's on the ParaBoss website. These are excellent tools for being able to predict the danger periods for Flystrike on your property, and it's well worth using these, particularly the ParaBoss Flystrike risk simulator, which we'll talk about a bit later, where you can vary your inputs to see what changes in management, the effect that they can have on your Flystrike risk on the mob. The other thing to do is monitor your sheep closely during times of higher moisture, and take a closer look. Actually do a hands-on job, parting the fleece and having a look at those sort of problem areas that need greater attention, rather than just sort of having a look as you go around them on the quad bike or whatever you're using. So these are a few things that you can do, because we can't control the weather. But taking advantage of these things, you will have a better handle on the potential Flystrike risk. And as such, you should be able to put some things into place, which we'll talk about a bit further on, to try and manage Flystrike a little bit better. Next slide, please, Fiona. Okay, so the third thing that's needed, really, apart from the weather, is susceptible sheep. And you can see there that we've got the DAG scoring index and also the visual wrinkle score. So everyone would be well versed now in what they need to look for in their lambs when they're selecting to be able to develop sheep that have a cleaner breech area, therefore less DAG and less Flystrike susceptibility. And one thing that we always may overlook but is very important is tail length. So that extra digit of tail length makes all the difference to being able to lift the tail, not only for defecation, but also for urine, to reduce urine staining. So the other area, and this depends on when you get rain, whether or not it's going to be a potential strike area, is the withers, and whether there's conformational weakness in your sheep, so that there is moisture retained at the withers. And often this is an area where fleece rot and mycotic dermatitis, or lumpy wool, it can start from that area and move out. But all of those breach and withers can be taken care of through your breeding program and selecting on those conformational traits. So, you know, if you run wethers, you know, do you have to worry about pizzle strike or not? Often that's not a problem unless there is pasture that's of a length that's wetting that area. And some people, when it's dry, you sort of forget about the areas of the back of the neck or the flanks of the sheep. But, you know, when you're getting consistent showers of rain, the sheep puts its head down to feed, the fleece opens up on the back of the neck, and they'll get strike on the back of the neck. And the flanks, if they're in high feed, you know, they can get struck on the flanks as well, anywhere where there's persistent wet areas. The other area we need to consider are wounds. Now, I'll talk in the next slide about fly species, but any wound is a potential area for strike. And also post-lambing, any soiling, like with the afterbirth on the fleece of the ewe, that's a great protein source for flies. And flies may, if it's still quite moist in that area, they may lay in that area because it would provide sufficient food to get maggots hatched out and started. And so the third thing is wool length. About 6 months wool seems to be the length of wool that is a problem when it comes to fly strike. Any shorter and it shouldn't be a problem, and any longer and the sheep have a closed fleece and it shouldn't be a problem either. So there are sort of lengths of wool that you might need to consider depending on the weather conditions. Next slide, please, Fiona. So the third requirement for fly strike, of course, is the availability of flies. So you'll all be very aware of what we call the primary flies, or those that initiate strike, and it's the little green one on the top right-hand side, Lucilia caprina. This, in the eastern states, is the main problem for initiating strikes, and it's generally reported as producing 90% of strikes in Australia. However, we do have what we call secondary flies, and these are what you know as the big brown blowflies predominantly. So in the eastern states, Calliphora stygia and Calliphora auger. But in the western part of Australia, they have sister species, which are Calliphora albifrontalis and Calliphora dubia. Now, there are reports from Western Australia that those two sister species, albifrontalis and dubia, are capable of initiating strikes. And also the one on the far right-hand side, Calliphora nociva. So there is the ability of some flies not to lay eggs, but actually to lay larvae. And so in the eastern states, that species is Calliphora auger, and in the western states, it's Calliphora dubia. However, there are reports of these other two western species, Alba frontalis and nociva, also being able to lay live young sort of when they want to. I'm not actually sure how accurate those reports are, but that's what's in the literature. So in the eastern states, we classify Calliphora stygia and Calliphora auger as secondary flies, so they come in once a strike is initiated. However, in that wound type situation, they can actually lay on a wound because there's everything already there that they need. The main one that you would be aware of, and I'm sure you've seen all of these, is the little green one that's next to those, which is called Chrysomya rufifacies. On the wing, it looks very similar to Lucilia caprina, but the maggots look very different. They're larger, they're darker, and they've sort of got spikes on them. And they're not hard to forget at all. I'm sorry, they're not easy to forget. And they're quite, they actually will eat the larvae of other fly species, and usually they're found on carrion. They will occur on an existing strike. If you see these on your sheep, it's an indicator that the strike has been active for several days, and it's often when these flies have been on the sheep that the sheep's life may be threatened, because sometimes septicemia can set in, and it's sort of a whole different ball game, really. Next slide, please, Fiona. So let's just talk about some basics about fly populations. You would all be aware that flies overwinter as what we call pre-pupae, and that spring fly numbers are dependent on the number of maggots that go into the soil in that autumn period. And so you actually can have some control over that through your strike management in autumn. So the more vigilant you are with your strike management and dressing and collecting those maggots and making sure that they are killed or die, the less flies that are going, maggots that are going into the soil, and that is one way of sort of trying to decrease that population that will emerge come spring. Luckily, when those maggots go into the soil and turn into pre-pupae and then pupae, they are actually open to predation by ants and a range of things. And also they're affected by soil moisture, so they can actually drown if there's heavy torrential rain. They're like you and me, they need to breathe, and if they get waterlogged, they can actually be killed that way. Once those pre-pupae are in the ground, when the temperature increases 1.5 degrees over 4 days, above 10 or 11 degrees, those pre-pupae will go on to form pupae, and then they will emerge as adults. And that's why we get a synchronized adult emergence in spring. So you've got a resident number of flies there that emerge, and then the rate that population increases, of course, goes back to the number of susceptible sheep that are available to those flies to strike. And so the rate that your population will increase is dependent on your spring strike management strategy. So you can sort of control these population numbers to some extent at either end of winter through your autumn spring strike management and your spring strike management. Another very interesting fact is that in the 80s, there was some great work done that showed that there will be 5 to 14 times more strikes that you don't detect than the ones that you do detect. So for every strike you detect, there may be 5 that you can't see. So covert are the ones you can't see, overt are the ones you do detect. And that proportion, the range 5 to 14 times, is dependent on the type of sheep and the conditions of the season. So thorough inspection is always the best way, because what you see at a glance, there will be far more than just what you can see at a glance. Next slide, please, Fiona. So again, one of the simple things to do is please collect your maggots and kill them when you're dressing. So when you dress your sheep, shear and dress on a tarp or something like that, so that you can pick the maggots up and easily shake them into a big bag, or a big plastic bag or something, and that you can seal and put in the sun to kill. And that will slow the population increase in spring, and it'll reduce that fly wave in spring if you collect and kill maggots in autumn. You also can have a timely preventative treatment already on your sheep when that spring fly wave emerges. But remember that the time that you choose to treat needs to be in the sweet spot. So we need the concentration of the chemical to be at its highest active level when those flies emerge. And of course, if you have sheep that are not susceptible to fly strike and those flies emerge, there'll be a fair proportion of those flies that won't be able to lay eggs, and they'll die of old age and reduce the population that way. But to do that, as I said, you need to have to have used effective chemicals, and it needs to be in that effective concentration range. So you can't apply a chemical and expect it to protect sheep, depending on the protection period of the claimed protection period, of course, if you treat way too early. There are a few other factors there that come into it, and basically these come again down to the amount of dag and soiling around the breech, so the wool length, effective worm control, if that's in place, green feed management in spring so that you don't get, scouring and lots of dag. And again, as I said, wounds and the time of lambing, so that soiling, ewes have had time to sort of clean up and not be a great source of protein and possible strike areas for the sheep, for the flies. Sorry. Next slide, please, Fiona. So when we said about effective chemicals and effective chemical choice, there's a range of things that you have to look at for your property. So first of all, you want to have a look at what is your problem. Is it just flies? Is it flies and lice, or lice on its own? And you can't consider it in isolation from drenching and dag prevention and management. So I suppose what it's basically saying is you need a whole year plan for this. It's not just a one-off, oh, I think there's going to be some fly strike, I better do something. You need to have considered all of these things. So another factor to consider is your application technique, whether you can jet or use you need to use a spray on, or if you're going to be dipping, or just dressing existing strikes. And as I said, with the treatment timing, is it too early? Is it too late? Or are you in that sweet spot of, yes, the flies are here, and yes, I know my chemical is at its most effective? That links back again, of course, to predicted weather events. It's no use treating sheep and then 3 days later they get torrential rain on them. You know, there's a lot of moving parts in this, and you need to be across all of these things. And whether or not you're expecting breech or body strike, and that'll be about the composition of your flocks. You know, do you have yearlings and weaners? Do you have ewes that are in lamb with reduced immune systems? You know, are there these vulnerable flocks? Where do you normally graze them? Can you put them in a paddock where there's greater wind speed so that the flies are going to be less troublesome to them? And you need to consider from your chemical what your required period of protection is. Do you want short-term protection or a longer-term protection? And you need to go on the label claim for that to match that up. When you are using treatments, please always use the treatment pattern that the manufacturer recommends to give coverage on breech or body, whatever you've picked, and that the wool length is as stipulated by the manufacturer. It also, effective chemical choices, you need to also consider residue and compliance to withholding periods, and you need to have this on your calendar as well. So there's a whole range of withholding periods, and I'm sure you know all of them, but we'll just quickly run through what they are. Sheep rehandling interval, SRI, that's once you've treated, how quickly can you actually handle those sheep again? Wool harvesting interval, sounds self-explanatory, but yes, it's the time from treating the sheep until you can shear. Withholding period is usually in relation to meat and milk in the domestic market. And export slaughter interval, of course, is the time from treatment until those animals can be slaughtered. So when you're picking your chemical, you're making your chemical choices, and you have your calendar, you must consider compliance to all of these different periods, so that you're you're outside of those intervals. Not only for your own safety, but for the safety of consumers. So the other thing that we need to consider when you're looking at effective chemical choice and application technique is that the concentration of the insecticide decreases not only over time, but often also around the sheep. Now, that diagram shows that sheep and the concentration of insecticide on the back line where a treatment has been delivered in a band, and then that the concentration decreases as you move from the back line down the side of the sheep to the flank. And the figures that are marked there it goes from 140 milligrams per kilo to 70 milligrams per kilo just from the back line down to the side of the sheep. So that's another thing to consider, and why it's so important to use those those patterns that are stipulated on a manufacturer's product, so that you can ensure that the concentration that you'll need to prevent strike is actually at the area where you need it. Next slide, please, Fiona. So part of effective chemical choices is rotation of the chemical group that you use practicable on your property. And if it is, it's recommended that you do rotate these chemical groups. And to do that, you need to consider what you used last time to prevent fly strike. So that doesn't mean, last time can mean in the last fly season. So it might be in autumn. You may have put on a application in autumn and you're considering what to use in spring, or it can be that you're going to do 2 treatments in spring. What did you use at the last treatment in spring? What did you or are you going to use as a dressing? Which chemical group are you going to select for a dressing? And then just, were these products successful? And if not, is there a reason for them not to have been successful? When you used your preventative treatment, for example, did you have rain straight after? Did you only apply it to the breach and then you got body strike? There's a whole range of different things to consider there, and try and get down to a reason, if it wasn't successful, why you think that could have been. And then you might decide that there is a better application technique or something that you're going to try, or a different application technique. May not be better, but it might be a different one and it might give you more success. The other important one is, what have you used for lice treatments? Now, I would be very keen for everybody, when they think about this, not to just think about what chemical group they used for lice treatments, but whether or not they actually need to use a lice treatment. So, do you have lice present in your flocks, and are treatment required? So not a lot of people, but some people do lice treatments as insurance treatments, as in they don't know whether they have lice or not, but they're going to treat anyway. As a rule of thumb, if you have lice introduced into your flock, it should be at low enough numbers that you wouldn't even know that they were there for a couple of years. So you have time to actually, if you think that there's been an introduction of lice, to actually get to the bottom of that, have a look, roll some sheep over and have a look and see if they've got lice. There's a lot of reasons why sheep rub, and some of, it's not always necessarily lice, especially the last 3 years. There's been lots of grass seed and prickle and a whole range of different things. And consider whether or not you actually have to do a lice treatment, and if you can avoid doing a lice treatment, that's a good thing. That's less chemical that's out there in the environment of the sheep. So you also, if you do a lice treatment, you need to think about the time of year that lice treatment has occurred and what that will mean. Is that lice treatment still at an effective level, and be there for exposure to flies when they emerge in spring? So that needs to become part of your annual management calendar, because you need to consider the effect of lice treatments on flies. And I suppose the best way to, in my mind anyway, to keep all this is keep good records. Keep good records of all of the treatments that you do, what you used, when you use them. If you're doing different treatments on different mobs on your place, keep those sorts of records too. A lot of people often only do a particular treatment on their weaners and yearlings and ewes, and make sure that you got good records of those and when you actually treated. You can then line them up with your weather records, and you can get a really good picture of what's happening on your place, and that'll give you that predictive. In your own mind, you can still use the predictive platforms, but you go a long way to knowing when your risk periods are, from your own intuition about what's happening on your place and from these hard facts. Next slide, please, Fiona. One of the great tools that you can use is this, and it's found on the AWI website, which is at the bottom of that slide. And it's a very simple guide to look at your chemical groups. So on the far left-hand side is the chemical group. And then there's the active ingredient for the products that are effective against Flystrike. Then there are the application techniques that are registered for those products. And you will see that some are only available as spray-ons, some may be available as spray-ons, jetting, dipping, and a dressing. Some products may just be jetting and dressing, and of course the OPs are only available for use now as a dressing and can't be used as a preventative treatment. The label protection periods are also listed on there, and you'll see that it says not specified for OPs, but in fact, because they aren't registered for protection, they don't have a protection period claim. Also listed on there are the withholding periods that we've already talked about at a glance, which is really, really handy. And then whether or not those chemical groups are also used for lice control. Now, just remember that the active ingredient that may be in a product for fly control may be different to the active ingredient for lice control, but they may still belong to the same chemical group. So you need to check out what chemical group they belong to, not what the active ingredient is. Because, for example, the active ingredient for the neonicotinoids for fly control is imidacloprid, but there are products that are available for lice control that are neonicotinoids, and the active is thiacloprid. Usually they do end and sound very similar, but that's just one of the things you need to check out, and go by the chemical group always. Next slide, please, Fiona. Another great tool is this Flystrike chemical selection wheel that's also available from AWY. If you ring them and request it, they will send you one. And this is a really simple tool, and I've just flattened it out in the table on the right-hand side so you can see it all at a glance. It has Prevention 1 and Prevention 2, which are your two treatments. So Prevention 1, you put in the chemical group that you used last time you treated to prevent Flystrike. Prevention 2 is the one that you're going to use this time. So what you choose to use this time, and you can also, you dial in also the chemical group that you used against lice, if you used one, and what you intend to use as a dressing. So for example, the example there on the wheel is that you've used an organophosphate as a dressing. You've used a neonicotinoid against lice. Previously, you used a synthetic pyrethroid to prevent Flystrike, and please note the synthetic pyrethroid Flystrike products are only registered for against body strike, not breech strike. And so you need to come up with a third chemical that isn't any of those three groups. So the dial there has selected the insect growth regulator group, or conversely, it could have been the macrocyclic lactones, which you would know as ivermectin. So across the groups, you can see there are the IGR, insect growth regulators, and those two chemicals are dicyclonal and ceromazine. The synthetic pyrethroid, which we've talked about for body strike prevention, the ML, which is ivermectin, as I said, neonicotinoid, which is imidacloprid, the spinosyn, which is spinosad, and the OP dressing, which is diazinon. So the whole aim is to not double up, and this is a really easy way to do it just based on colours. You can easily see that you haven't you haven't repeated using the same group, and either last year or for lice or as a dressing. Next slide, please, Fiona. So when flies and maggots are resistant to an insecticide, what are we actually talking about? So resistance is usually a single genetic change that alters something in the animal, in the insect, that allows them to overcome that insecticide. Now, that might be they can detoxify it quicker, or they can immobilize it out of their body, or the target site that it normally is active through becomes less sensitive. And if that occurs, if I have a look at fly populations in Australia, normally you would see, and on the left-hand side, you'll see that a graph there where it says a single resistance mechanism. You would see a normal population is on the group of populations are on the left-hand side. These could be from a variety of states. And then suddenly to the far right of that, you will see on the same graph that a couple of populations have emerged, and there's a big difference and distance between the response of these resistant flies and the normal susceptible populations that occur on the left-hand side. This has been demonstrated by organophosphate resistance in Australia, and this is what the results we found in 2018 to 2020 when we graphed the response of the 100 strains that we got from across Australia. And we got a normal bell-shaped curve, but what you see on the little green square on the left-hand side, that's where the populations used to be before resistance developed. So that's where susceptibility is. And all of the flies are resistant, all of the populations are resistant as well, and they bear no relationship to each other anymore. So the new normal for organophosphates is that curve on the right-hand side. Next slide, please, Fiona. Another term that you would have all heard about was cross-resistance, and the best way to explain cross-resistance is when you've got chemicals from the same group and they may be very similar in their chemical makeup and their shape, really. And those two chemical formulas that you see there, one is ceromazine and the other is dicyclonol, and you can see just how similar they are, even though they're not identical. There's a few, an extra carbon in dicyclonol and a triple bond to nitrogen, which makes it different. But it's sort of analogous to having an old wardrobe with a key. And I don't know whether you're old enough to have done this, but usually a wardrobe key would open all wardrobes because the key was fairly generic and the locks were fairly non-specific. So cross-resistance occurs in a chemical group because even though those chemicals are not exactly the same, they are. There is enough latitude in that insecticide resistance mechanism to allow for the detoxification or whatever the mechanism is to occur on all of the chemicals that occur in that group. So that's what cross-resistance within a chemical group is. It's this sort of one size fits all really within the group resistance mechanism. So the graph on the right-hand side, I don't want to get too technical with this, but normally when we graph the response of a strain when it comes in the lab, I expose it to a whole range of different concentrations of a single chemical and I measure the mortality. And if you plot the mortality versus the concentration, you'll get these straight lines when you put it on a log scale at the bottom. And there you can see the line on the left-hand side is the susceptible line. So that's the response of a susceptible strain to a chemical. And the one on the far right-hand side is a resistant response. And what you will see is that neither of those two overlap. And so that's what we see. There's a big shift between the level of sorry, I've just lost my train of thought. How we characterize these strains is that the horizontal line goes through the concentration that causes 50% mortality in each population. And so for the susceptible strain, that's the value that we would normally quote, called the LC50. And you can see it's quite different to what the LC50 for the resistant strain is. If you cross individuals, a single susceptible individual and a resistant individual, their offspring will be what we call heterozygotes, or you might call them hybrids. And then their LC50 is going to be intermediate between those two. And we can tell a lot of information about the resistance based on looking at these types of graphs of individual strains. And then we can tell a lot about what's happening in Australia by looking at the response of all of those strains or populations together. So just take home from this is that there's a big separation between susceptible and resistant, and therefore there's a big range in concentration difference between what concentration will be effective against a susceptible fly or against or maggot, or against a resistant fly or maggot, and that is seen on the sheep as a period of protection. So you don't get complete failure. It's not that a chemical won't work at all. It's just that that period of protection will decrease as resistance increases. So no complete failure, just a reduction in protection period. However, it's not just a reduction in protection period. That also has to be taken into consideration when you're choosing your chemicals and you're looking for effective prevention of fly strike. Next slide, please, Fiona. So there is a different sort of process that goes on at the same time, and it's a reduction in susceptibility to an insecticide. So again, this is sort of a hypothetical. If you have a look, the navy blue stripes would be, if I plotted the response of a whole heap of strains from Australia to an insecticide just when it's been released, you'll see that the area that it covers on that graph is quite tight. The most of the populations fall in a very narrow area, and there's not much variation in the population's response to that chemical. If I look at it in another, say for example, 5 or 10 years down the track, you may find that that response in those strains has moved out along that x-axis. In other words, there's more variation occurring in the population. It's not that resistance has developed, it's just that some strains are less susceptible than they were when it first, when the chemical was first introduced. And then if we go again to time 3 further down, you'll see that the range of response spreads out even further, but you'll still see that it actually does still overlap with the original response at time 1. So this is what we call a shift in to less susceptibility, or strains are becoming less susceptible. And usually what you'll find is you will still get strains that are quite susceptible, but that the concentration ranges that were effective before have broadened out. Next slide, please, Fiona. So this is a resistance update. These are the results that we're currently producing from the project that we're running at the moment, co-funded by New South Wales DPI and AWI. We've had strains submitted from every state, a sheep producing state in Australia. And you can see that these are the 5 chemicals that we test: dicyclonol, ceromazine, spinosad, ivermectin, and imidacloprid. N equals is the number of strains that we've tested, and you'll see that we've tested more strains against spinosad, ivermectin, and imidacloprid, and that's because I've put the results from 2018-2020 in with the results for last year to get a bigger data set. We use a different test for dicyclonol and ceromazine, and unfortunately we didn't do that test in 18-20 in the project from 2018 to 2020. We used a different technique. So those N equals 72 is the results from just this 2023 year. And the red line is trying to give you an impression of what's happening with these chemicals based on what we just learnt about this move to less susceptibility. The dicyclonol line, let's start with that one. There is a population there are populations over on the left-hand side that are apart from the main population because it goes down to 0 where it's down. And so what we've seen is these are resistant strains, and the one or two strains that are left on the left-hand side are the sort of remnant low level resistant strains. To date, we haven't, in this project, we haven't yet been able to find a strain that is not classified as resistant to dicyclonol. So this is what the graph looks like, and we would expect that where the point is up high, that will shift across to the middle over time, and then similar to OPs, you know, we'll have a different population graph to what we had when things were susceptible. That doesn't say that there's not susceptible populations out there. It's just that we haven't had any sent in to us. So the more we get sent in, the more we look at, the more idea we can get about what is actually happening with dicyclonol. It's a similar thing with ceromazine, except all of the strains haven't shifted to the right-hand side. There's one or two strains that are more resistant to ceromazine than the bulk of the strains. We'll be very interested to see, because we haven't yet found a strain that's not resistant to ceromazine either. It's an interesting thing with ceromazine that you can get strains that are ceromazine only resistant without dicyclonol resistance, but we haven't found any strains that are only dicyclonol resistant, not ceromazine resistant. And sorry, I misspoke earlier. We have found some strains that aren't dicyclonol resistant. We haven't found any strains that aren't ceromazine resistant. So all 72 strains are resistant to ceromazine, not all 72 strains are resistant to dicyclonol. Sorry, I misspoke before. Let's look at spinosad. So we know, because we have data from prior to spinosad being released in 2001, we've had this move towards less susceptibility. And you can see that because there is a little on the left-hand side of that chart, but it's still continuous with the rest of the population. Same with ivermectin. You can see it's sort of shifted to the right a bit as well, this move to less susceptibility. And then we come to imidacloprid. Now, the interesting thing about imidacloprid is that we don't have any data from before it was introduced for lice control. And it was used for about 10 years before it was registered for blowfly control. So there appears to be this shift to the right-hand side with a fairly long tail. We don't have that pre-exposure data to know exactly how far that shift has occurred. But this tail out to the right-hand side is well worth looking at and considering, because clearly there is this move to less susceptibility. If this continues to go out further based on these, by looking at graphs, not on anything else, we may be looking at a situation where there is resistance in its own right. And we do know from work that we did in 2018 to 2020 and other work that's being done in Queensland that there is a correlation between dicyclonal resistance and imidacloprid resistance. But we also found that there was a relationship between dicyclonal and seromazine resistance and diazinon resistance. So with resistance, we're looking at a legacy situation where these resistances, they can go away if selection pressure no longer exists, but often, like the case with organophosphates, they actually stabilise in the population and they're there for, forevermore. So imidacloprid, we're looking at this very closely. And we'll keep you abreast of what the outcomes of this is. So again, all of these things, all of these graphs indicate that rotation is a very good idea, so that you're not just using that same chemical over and over and over to entrench and keep shifting these graphs over to the right-hand side. Next slide, please, Fiona. So I got cobbled up before, I apologise. This is just a brief summary of the project we carried out in 2018 to 2020 and what we've done so far just in the last 12 months. We haven't, as I said, we haven't found any strains that are susceptible to both seromazine and dicyclonal, whereas in the previous study we had 12%. Predominantly these were from Kangaroo Island, South Australia, Western Australia, and one from Tasmania. We haven't found any of those as yet. Resistant to seromazine only, 9% in 2018, 12% in the current study. Resistant to dicyclonal only, as I said, we have never found a strain that is only resistant to dicyclonal and not to seromazine. And resistant to both, 73% in the previous study, 85% in this study. And what is of concern is that we've found that 3% of those have seromazine resistance at a higher level than we've ever detected before. We screen these strains with specific doses, what we call a susceptible discriminating dose, and then 4 times that to categorise the difference between low level and higher level. And we've never had survivors at this 4 times the susceptible discriminating dose before, and this time we have. And along the bottom, you can see how many strains we tested from each state. Western Australia last year, we got a great response from them. We always get a great response from New South Wales, and we're very, very pleased to have had 6 submissions from Queensland and 3 from Tasmania. And we're putting a big effort into getting more samples from Queensland, Tasmania, and Victoria and South Australia. However, we're also canvassing for submissions from Western Australia and New South Wales. More information we get, the more certainty we can have around these results. Next slide, please, Fiona. So as I said, there are other reasons for shortened Flystrike protection periods, and if you find that a product hasn't performed as you would like it or expected it to, according to the label claims, procedure is that you should go to the company that produces that, and they will do an investigation which they have to report to the findings of to the AVPMA. And these are a few things that you can look at yourself. They'll look at them, but you can look at these yourself, whether you've used the correct applicator or not, whether the dose rate that was applied was correct or incorrect, whether if there is a wool length that's stipulated, whether it was the correct wool length or not, what the weather conditions were after application, if there's an unrealistic expectation of the chemical, for example, were there, did you have a high DAG score? Were there wounds? A whole range of different things like that. And some of the products actually stipulate the amount of fly challenge. So they may say that they're active against Flystrike, but only under low to moderate fly challenge. So these are all the things that you need to look at, and probably you need to consider these things as well. Definitely need to consider these things as well when you're making your product choice. Do you have the correct applicator to apply that product? You know, have you bought enough, or no use dialing down the gun if you haven't brought enough, because then you're putting a lower dose on each sheep than what's required. All of these things need to go into the mix, not only when you're troubleshooting if you don't get the protection period that is stipulated, but also when you're making product choice. Next slide, please, Fiona. So this is a horrible slide, and I do apologise because there's heaps and heaps of information on this, and you probably can't read it because the writing on the left-hand side is in such a small font. But this is actually taken from AWI, what's known as the causal web for Flystrike. So all those factors that feed in and sort of feed into Flystrike and are all interlinked. And you'll see, I don't know whether you can see on the left-hand side, but there's things like wool versus hair, fleece diameter. So there's fleece factors, there's sheep factors, you know, there's a whole range of different things, some of which you can modify or get rid of or change by control or by genetics, breeding out in your flock all of these bad traits. And so they've got a green tick next to them. So the aim of this slide is in fact to show you, yes, there are tons of factors that feed into Flystrike, but there are a whole range of them that you actually have control over and can do something for. Of course, there are some that you don't have control over. And I suppose over here on the right-hand side, it's easiest to see because the font is larger. You don't have control over adult survival of flies or whether the gravid female can locate sheep or not, because that's actually what, that's actually what flies are best at doing. But you can control some of the factors around those that may feed into it. You'll see there's two R's. One is sterile male release and one is environmental fly management, e.g. trapping and using insecticides in a different way. And they're things that are currently under research or being carried out in trials. You may well be familiar with the sterile male release that's occurring on Kangaroo Island at the moment. Perth is carrying that out. And just at the beginning of this year, we completed a 2-year study, and the final thing we did was trying to prevent spring fly strike down in the Yass Valley. And we successfully did that by releasing infertile male flies every 2 weeks. And there was no fly strike on the property from we started the releases at the end of August, start of September, right through to shearing, which was in January. So these things have been proved sort of in field trials and things like that. I suppose they'd still be classified as, they're still classified as research at the research level because they've not been wide scale and freely available to everybody at this point in time. There is a whole heap of work going on about insecticides, and one of those is being carried out in Queensland, and you may be familiar with the nanoparticle technology that's being used to try and deliver the chemicals that are registered, but in a nanoparticle format, so to increase effectiveness. So there are, as I said, there are things that you can't control, and most of those are the environmental component to fly strike. But through genetics, management and planning, everything there with a green tick can be either controlled or modified. Next slide, please, Fiona. So the fly strike management tools that we've discussed today, and which I would, heartily endorse for you to if you aren't already doing these things, I'm sure most of you are, but to sort of have a look at, like I said, weather stations and your records. You can work out for your own property critical timing and thresholds. Some people have higher thresholds for fly strike before they will treat. Other people don't have any threshold. They don't want to have any fly strike at all. But each one of those systems has advantages and has a disadvantage. It has disadvantages, and you need to be aware of what they are. Fly strike modelling scenarios. So on the FlyBoss fly strike risk simulator, this is a great tool where you can get on. You can. There's a online version or a downloadable version, and you can actually pinpoint your property. It will call on 30 years worth of historical weather data, and it predicts when your breach strike risk is the highest or your combined fly strike risk is the highest. And you can modify a whole range of different factors. For example, your shearing times, your crutching times, your treatment times, and you can have a look at what it does to that risk. And so it's a really, really handy tool if you, for example, have an opportunity and so to look at this and say, what happens if I change my crutching date by 4 weeks? You can put it on there, in there, and you can see what happens to fly strike risk. And it can inform you in many ways, because we would advocate that we need to be moving away from a reliance on chemicals. And so this is a really great tool to look at the effect of what those other things like shearing and crutching, and getting the most protection out of those procedures that you can for Flystrike. The chemical selection wheel that's on the AWI site, so you can dial up and try and make rotation a reality on your property, chemical rotation. And then a complete seasonal and annual plan for your complete operation. There's a whole range of information on this. There is something on ParaBoss about annual Flystrike management planning. And there is a whole AWI Flystrike extension program, and the link is there, which will provide you information, which I'll talk about on the next slide. But the final thing I want to refer you to is the information that's available from your state departments of agriculture or their equivalent. They usually have good information sheets that are specific for your state and the conditions that you see, and the type of sheep too that you have in your state. And that gives you a really good, more than an Australian general point of view, it gives you a really good information base based on your state. Next slide, please, Fiona. So this is the AWI Fly Extension Pro that I just mentioned, and there's a link to it there. And they've got a variety of information sessions, and the format of that depends on which one of these products that you actually click on. Please go to their website, have a look at them. There's a whole resource there. You can look on each different component of that extension program, see which one suits you. You can go from everything from, listening to a talk that explains the basics of flies through to even working with someone and planning your annual calendar, Flystrike calendar for your property. And it's well worth getting on and having a look. You know, it's supplied by AWI, and wool growers should not hesitate to get on and have a look at this. Next slide, please, Fiona. So the final thing is I'd just like to give a plug for the project that we're currently doing. The little map of Australia has got 72 pins on there where you can see where we've received samples from. As I said before, we'd be very keen to receive more from Tasmania and Queensland, South Australia and Western Australia, but actually we'd be keen to receive them from each state in Australia, because the more information we get, the more veracity we have in these data that we are developing to inform everybody about what's happening with insecticides and insecticide resistance in Australia. We hope to be able to give, at least at the state level, but hopefully the regional level and maybe even further down, information directly back to people, because we also have a collaboration with the University of Tasmania and the University of Melbourne, and Dr. Brian Horton at the University of Tasmania, who developed the Flystrike risk simulator that's on the ParaBoss website, has now included resistance in his modelling, and we are using the data that we're collecting from real-world submissions here in Australia to validate his model on resistance development. And once that model is developed, we should be able to give recommendations that are highly relevant to an area back to people about what the model says about the development of resistance, how quickly it can it is developing, or, for example, the with the benefits of rotation. You know, rotation, I understand that for a lot of people it's not an easy thing, but if we can demonstrate the advantages of that, it may be sufficient to sway people to really get on board that rotation train for not just blowfly control, but also including lice control. If you would like a maggot collection kit, please email me or telephone me, and we will post one out to you. It's as simple as collecting 30 to 60 maggots. You put it in little containers, 2 containers that are in the pack. Fill out the submission form. It does look like we're asking for a lot of information, but that's the information that we need to go along with the results from the submission, down to Dr. Brian Horton at UTAS, to pump into his model, to do that validation and to do that modelling. So that information on the submission form is very important to the project. It's all de-identified. Your privacy is 100% guaranteed, and your results go back to you, but once it's identified, it just becomes aggregate results. So, hopefully you will be able to put a submission into us, and that you shouldn't have any qualms whatsoever about privacy. Next slide, please, Fiona. Okay, so we'd just like to acknowledge that AWI funded the 2018 to 2020 project and the current project, which runs until June 2024. And that's AWI is funded, of course, through wool grower levies and the Australian federal government. Thank ParaBoss for the Flystrike risk evaluation risk model, and New South Wales DPI, of course, because they've co-funded both of these projects. And there's a little disclaimer there that just says that AWI and New South Wales DPI can't be liable for any loss or damage, that this is information that's contained in this presentation is for your consideration only. You know, we're not going to tell you what you can do or can't do, but certainly we'll provide you with this information and hope that you have a little bit more information to make informed decisions on your property around chemical choice and insecticide resistance in Flystrike. Thanks, Fiona.
Thanks very much, Narelle, for the presentation. That was fantastic. It's now a chance for us to start our Q&A session. So if you would like to enter your questions into the Q&A tab, and we will do that. Perfect. Great. So I've got one question that's already come in. So we would like a slightly bigger Q&A time. So get your questions rolling in, everybody. First question is it possible to get the reference for the incidence of covert strikes 5 to 14 times?
Yes,
earlier on in your presentation, because I saw
that. I can pull that out. That's no problem at all. Yep. Just how, if I give that to you, Fiona, then you can pass that on.
Yes, that will be fine. I'm just writing down the details of who asked that question.
Yes, I've made a note as well. Yep.
Great. Thank you. Any more questions, everybody? Still quite a few people online today. Put that down. I have a bit of a question for the collection of the maggots, Narelle, if you'd like to be part of the trial, do you order your kit beforehand and then wait to see if you get strike? Or once you get strike, is there some way of storing and then you can order the kit and get it sent up to you?
So there's nothing that's perishable in the kit. The little containers just contain vermiculite, which is totally, it's what's in potting mix to like an absorbent material. So it's totally inert, and there's nothing perishable in it. So if you are interested, my suggestion would be to contact us and have one on hand, because I've done this myself where suddenly you're pounded by strike, and all you're doing is dressing sheep, and really your last concern is about getting a kit to collect maggots. So I would suggest that probably if you have it beforehand, it's probably the best way to go, I would say. You can have it knocking around behind the seat in the ute or something or other, so that when you do dress sheep that you've got it there on hand.
Okay. Questions just come through. Have you published the resistance data for each chemical?
So there was an annual report that came out from the last project, but we haven't actually got a publication. We have got a publication because in that project we did an implant trial where we looked at what the protection period of chemicals were using resistant and susceptible dicyclone and seromazine resistant and susceptible maggots on sheep, and that's been published. But we haven't as yet. We're looking to combine what we get from this and the previous and write a paper, because I think what we will be able to see is any shift between those two time points, because it's 5 years now since 2018. So we're actually looking to see if there's any shift in those at those points as well. So the answer is no, but we will, and hope with more data that will, which will be more robust. Yep.
Next question, how long has diazinon been banned from being used as a jetting agent?
Oh, when did that? I can't tell you the exact year, but it's it went off because it's actually been taken off because of work health safety. So it's the risk to humans that's the reason that it was no, and I can find that out and I can tell you that as well, Fiona. I'll do that. I'll have to look at AVPMA for that.
If you're using ivermectin, what product would you rotate next for jetting?
So you would need to look at your wheel, because it would depend on what you've decided to use for a dressing. So, for example, if you've decided to use actually, spinosad is a good one to use for dressing, because it only has a 4-week claim for protection anyway. So really, it doesn't afford you very much in that protection space. So if you're using ivermectin, your alternatives are imidacloprid, dicyclone, seromazine. That's it, really, looking at the list. And this is why rotation is important, because even if you do have resistance to dicyclonol or resistance to seromazine, chances are you're still going to have to use those chemicals. But if you're using them as part of a rotation, it's a lot better than just using the one chemical over and over and over. So it's a bit of a holistic thing, this, really.
Excellent, thank you. That's all the questions that have come through. Thank you everyone for staying online for so long. It was a long webinar without few little IT glitches at the beginning. So thank you very much for persevering with us. It was great to have you online. I'll send you off a short survey this afternoon. So I thank you in advance for filling it in. And thanks, Narelle, for joining us. It's been wonderful to have you online with us today at ParaBoss.
Thank you very much. Thank you, everybody.
Bye for now, everyone.